Okay. So this is 0.5 meter. How many agree and how many disagree? Somewhere here. Hello, good to see you. Okay, that's nice. And here, good morning, Janab. Good morning. This is nice and beautiful 0.5 meters. Done? Okay. What was the question? You again, I was just not sure how many students are coming. Sometimes 20 comes. Good to see you. Sometimes 10 comes. So okay, omega AC equal to question mark omega AB equal to question mark AC equal to life is beautiful equal to AB equal to omega CB equal to question mark, and then I have hello, good to see you, alpha AC equal to question mark, hello, alpha equal to AB equal to alpha CB equal to question mark. Done? So do it. We still have 3 minutes. Okay, so what you have on your desk, you are not going to follow this because I have changed the coordinate system, right? The coordinate system I am following is different. What the author is following is different. And the coordinate system of the author is, of course, way better than this one. But we will go through the hard way. Okay. So it doesn't help. What you have on your desk just doesn't help. You cannot do anything. Okay. We still have 2 minutes, so let us wait for our students. Okay. I think we cannot do anything if I don't name them. So this is my A. This is my C. Let's call this point as my B. Okay, so I have already explained this question in the last class that because it is a slot, when it comes here, you will have distance of point, yeah, distance is changing, right? Okay, so I think if you do some coloring, it will be helpful. Let me add some color or probably a red color. I did explain that the distance is changing. Just impossible for me to color the edges, by the way. So I think you get the point. Peter, you have to switch on that, I think, red button. Really? Okay, anyways, that's fine. So we have a
waiting for a couple of minutes because I'm coming from minutes to 19 and I didn't Take a break.
That's fine. That's fine. That's fine. Okay, everyone, let's start. So what I will do, I have to find the omega AC. I have to find the alpha AC. So let's get going. Everything is provided to me. In an exam setting, if you want to make your coordinate system here, I have no issues. If you want to make it here, I have no issues. You want to put it here, I have no issues. As long as you draw a coordinate system. Yeah, that's the page. That one. Okay, now we have a VA equal to VC plus omega AC multiplied by cross product R AC plus V A with respect to C small xyz, which corresponds to the relative motion. Yeah, because the slot is, I'm sorry, the piston distance is changing with respect to point C. Because when it arrives here, you can imagine that this distance would have reduced. I have explained this in the last class as well. What is the value of VA? All of you told me last time. Just don't forget to pick one of these pages. If someone doesn't have, you can use my page. Okay, and although you won't be using that, by the way. So VA is equal to 3I plus 0J equal to what is the velocity of VC? It is equal to 0 because point C is not going anywhere. So VC equal to 0, and then I have plus, what is the value of omega C? I have no idea. But when the piston is going towards the right, then this whole rod is going clockwise. That's my intuitive feel. That's my intuitive feel. So because the rod is going clockwise, I will say, let's remove the vector. I will have minus omega AC K unit vector position of A with respect to C, which is wrong. Sorry. I will, but I made a mistake. A with respect to C. Okay, which part? The clockwise? So for example, the piston is going towards right. And where is your rod AC? This one, right? This whole thing is your rod AC or AC. So when the piston is, I need to have that mic, so I can roam about. When the piston is going towards right, then the whole rod is going clockwise, no? So it's my intuitive feel. You can disagree with it. So I will remove the arrow and I will put minus omega AC K unit vector multiply by, I made a big mistake here. In an exam setting, you write AC, I am deducting your points. You have to write A/C, A with respect to C. Because I am talking about A with respect to C, A with respect to C. Here you write AC, no issues. BC, no issues. So A with respect to C is, last time you already told me, it is minus 0.5 cosine of 30 I unit vector. And then I have A with respect to C has, like A with respect to C is towards left and towards up. So why don't you tell me? Okay, good. 0.5 sine 30 J. Boom, over, game over. Plus, now this is where, oh, come on, where is it? Yeah, this is where you will do the mistake if you have to in an exam. It is very tempting to put a 0 here, but you have to understand is as the piston arrives here, this distance changes. Since this distance changes, I would say that there is a VA with respect to C small xyz. So technically this piston is like me, who is on a rotating disc, who is walking towards this point C. Distance is changing. So I think the only confusing thing is what is going to be the direction. So I have this intuitive feel that this fellow is coming towards this. I will put an arrow like this. If I put an arrow like this, then it is it will have two components, downwards and towards right. So I will write VA with respect to C bracket small xyz. That tells me that we are talking about relative motion. Cosine 30 I. Next component. What will be the next component? Minus
V C times J.
sine 30 J. Good. You don't understand, you stop me right there, okay? Huh. Yeah, why not?
So instead of position of A respect to C, why did we take it from point C and not from point A? Because we're trying to find the position of A with respect.
So we are talking about A with respect to C. So we are talking. What is your question? Your question is about this one?
Like we took like negative 0.5 cosine of R.
Yes, yes, good. So A with respect to C means I am standing at C and I look at A and A is towards left of me and sitting upward from me.
So we
Okay, good. No worries. Just keep asking me questions because okay. Okay, done. So put a little bracket here, small xyz, and two equations, two unknowns. You do it. Do it. Piece of paper. Okay. Okay. Do it for me quickly. I multiply with J is K. Two equations, two unknowns. Give me the value of omega AC and BAC XYZ very quickly. Now when I am teaching theory of machines, the same stuff is happening. So if you are really good in this, that course you will sail through. So I have to proceed with you. Did I switch on the recording? Yes, I did. 3 equal to hang on, plus 0j equal to, so I cross j equal to k, I j k. What was that? I never remember. Like I cross j equal to k, j cross k equal to I, k cross I equal to j, and you flip them so a negative sign appears. Okay. Oh, come on. K cross I is a j. Okay. Minus plus, right? And I have k cross I is a j. Nahin. Yes, k cross I is a j. Minus omega AC. What did I do? Yeah, sorry. There is another bracket. Yeah, this is the part where that's why you have to help me in this. Okay, then I have minus omega AC 0.5 sine 30 and k cross j is a negative I. Okay, then I have plus VA with respect to C small xyz. That tells me at which speed I am going towards the center of the disk or going away from it, and minus VA with respect to C small xyz sine 30 j. It's very easy to make mistakes. I have to double check. Positive j unit vector omega AC, correct. Positive 0.5 sine 30 I unit vector, correct. Positive I unit vector, correct. Negative, good. Okay, Tahshin Chan, why don't you solve the two equations for us, please? Help us. Okay. So, and Ahmed Sajawal as well, by the way. What? Okay. So, okay, I will be using a yellow marker which never shows up, by the way, here. 3 9 3 Oh, come on. Where is I? Yeah, this one. Then this chunk. So I will get a very beautiful. I need some space, by the way. So I am removing this. Okay, I think I have made my point. You put the coordinate system anywhere in your paper as long as you make it. Okay. You put it here. Yes.
For velocity A with distance C.
Small x, y, z.
We decided that the AB goes towards down, right? We choose direction.
Don't say the word AB. We say that the distance between A and C, the piston goes towards C. The distance of A and C is reducing. So piston is me, rod is the disc, and you can clearly see that I am walking towards the center of the disc.
Yeah.
So A with respect to C, small x, y, z. A with respect to C is going towards C, down. So down means positive cosine. Achha, okay. Yeah, why not, please?
So the reason why BC, vector BC is equal to 0 is because we took the reference on point C.
The reason the reason I'm saying is I put it in a very simple analogy that this whole mechanism is not on the back side of a truck. So this system itself, the whole chunk is not going anywhere. So the point C is sitting here. On it there is a slot. The mechanism is going left or right. This point is not going anywhere. If it was sitting in the back side of a truck and if everything was going at a particular direction, then I would have said that VC also has a velocity. So I put that disc on the back side of a truck and then I start walking on that disc. Then we would say that the center of the disc also has a velocity. But as long as I have a disc here and I'm walking on it, the center of that disc has a 0 velocity. The center of that disc has a 0 acceleration. Okay, gentlemen, on that note, please help me with this equation quickly. 3 equal to a 0.2. Okay. What is this? Good. 0.25. Omega AC. Good. Plus. Okay. This little bracket, small xyz. You said root 3 by, okay, 0.866. Okay, 0.86. Okay, and the second equation is, let me use a nice, beautiful red color. 0J, right, is equal to 0.433.
Yes.
Can you please double check, everyone? Omega AC. Last semester, literally, I was using a calculator along with the class inside the class. Okay, minus 0.5. I think he is answering by looking at here, minus 0.5. Okay. With a J unit vector, with a nice and beautiful A with respect to C small x, y, z. Equal to, okay. 2 equations, 2 unknowns. Please give me the answer quickly. Omega AC is equal to 3. 3. Good. Okay. We have a chat. V is 2.1. No, 2.6. 2.6 is in my notes. So always put a bracket. You remove the XYZ in the exam. I am deducting points. Small XYZ mean with respect to that rotation, how much the fellow is coming towards or away. You remove the small XYZ, points are going. 2.6. Done. Clear? In an exam, I can flip the question. In an exam, I will tell you if the VA with respect to C small xyz is 2.6, I can flip the question. And the omega is 3. Give me the velocity of the piston. So far, so good. Sure. So do the acceleration for me then. Why don't you give me the alpha? And hang on. Omega AC that you have found is the same as omega AB. is the same as omega CB. You have to be crystal clear on this concept. Okay, that omega on a same one rigid body is the same, but the velocity at one rigid body which is rotating, velocity can be different. You know that, right, everyone? All right. Okay. Okay, find the acceleration then. Like, trust me, it's like just a fresher problem, the velocity part. It's the acceleration that will push you. Where should I put this? Let me start the problem.
I see just if you were reaching many things and if I start writing problems now
Okay, got it.
and it's the next
Got it.
one.
Got it. Okay. So acceleration formula I did not write here. It is from the previous class. So you may want to. I don't know. Should I write this formula? Okay. Right after the class, I will take you the national. In short, you can just start the problem. Hang on. This is what I want from you. You guys say this? Okay. Yeah, A is given to me. Look at that 1.5 meter per second square, right? So right up 1.5 meter I because x y is defined equal to, which is what AC is 0. From here onwards, just from here onwards, whatever that just follow the steps from here onwards. Okay. 654. Okay, I'm going to the next slide, everyone. 654321. So, boom. Oh, come on. AA equal to AC, right? Should I change the color? Okay. Plus omega AC or whatever that is. Hang on. Omega AC, AB, CB doesn't matter. Cross position vector of A with respect to C plus. Isn't it omega dot? Yeah, sorry. Omega. Easy to make mistake here. Omega square R, right? Plus omega dot, as one of the students said, I am more inclined towards using the symbol alpha, but if you want to use omega dot, I have no issues. R A with respect to C. You write here A, you change this from instead of A slash C to C slash A. No. Problem is a goner. The points are gone. Okay. Don't do those mistakes. In a pressure situation, it's very easy. Okay, so I don't want you to be too much afraid of losing points. That is again a very bad thought that you keep on thinking about points. My point was that your problem will be wrong. Okay, so forget about points for now. This is not a good thing to think about points. Hopefully everyone can get good points. Just focus on the learning, okay? small xy. Okay, did I make a mistake? No. So what is AC? 0? Okay. What is my omega AC? Hang on. What is AA? 9. 1.5, right? 1.5 in the I direction. Just one more thing that I want to emphasize. This is a different coordinate system. So whenever I am doing this, you will not see those answers here. In this, the coordinate system is stated where the coordinate system is y upward and xward aligned. You don't see the answers from here. We will see the final answer. Okay. Hang on. Omega AC, did we found? Come on. Yeah, yes, you're right. Hang on. Omega I found as 3, as one of the students said. So it is, what was the sign? Sign was positive. Sign was positive. So sign was positive. This means I assumed the direction to be clockwise. And if the sign has also come out to be positive, then whatever direction I assumed, maths is agreeing. So it's clockwise. So what should I write? 3, right? Negative or positive? Good observation. Again, this is one of those classical mistakes that happen because my assumption was clockwise previously. That's why you see in your notes, it's minus omega AC k unit vector that I wrote there. The answer came out to be positive 3. So maths was agreeing with me. Since maths was agreeing with me, the rod is having a clockwise motion. Now I have to use negative 3 k unit vector because maths tells me you are right. It is clockwise motion, and clockwise, as per our frame of reference, is negative k unit vector. Okay, so it is R A with respect to C. I don't know what was that, minus 0.5. A with respect to C cosine 30, and then A with respect to C is positive 0.5 sine 30. J, okay, plus alpha is unknown. Again, oh come on, what is this? Please let me have a look. Okay, intuition. The rod is going clockwise, so I have this intuitive feel that when the piston is accelerating towards the right, the rod might be having an angular acceleration. Its omega would be increasing clockwise as well. Again, that's an intuition. Acceleration and angular acceleration are very hard to have an intuitive feel about them. Okay, your intuitions can be wrong, but my intuition is minus alpha k unit vector. You can disagree with me. Okay, so I plus 0.5 sin 30 j negative 3 k. Okay, cross product minus 0.5 cosine 30 I plus 0.5 sine 30 j, done, plus 2 omega. Okay, what is omega AC? Minus 3, right? Because of my previous, and cross, okay, velocity of A with respect to C small xyz. Hang on. Look, all of you told me that this is our answer, and please be careful. Here you have to mention that my clockwise assumption turned out to be correct. Omega is clockwise. What about VA with respect to C small xyz? The answer came out to be positive. And I still remember that I made these arrows, if you remember. Wow. This means maths is telling me you were right about your assumption that the piston appears to be going close to this point C, which is very intuitive. For sure it is going. So this means I will be using the same positive 2.6. 2.6 cosine 30 towards right, I minus 2.6 sine 30 J, correct? Okay. Okay, plus, okay, again, the $1,000,000 question. What is the acceleration of A with respect to C, small xyz? Zero or non-zero? Non-zero, in general, non-zero for sure. So, okay, intuition. Let's go back. A with respect to C, if this fellow is accelerating towards right, I have an intuitive feel that A with respect to C small xyz is towards this. Again, this is an intuition. You can disagree with me. So I will say remove the top arrow. Why don't you tell me, by the way? Cosine 30? But where is it in my notes, by the way? Okay, it's good. I did it. Cosine 30 I minus AAC. By the way, the students who are answering, how are they answering? Because this is the arrow towards right and to the bottom. Okay, minus sine 30 J. Oh, come on. Now, solving this becomes just solve it now. So this has a plus 0 J. These questions are just crazy. Okay, I and J. Now use your imagination. Write 1.5 I unit vector plus 0 J. You need to do this, by the way. So I cross J equal to K and keep doing it. And just tell me. This is just bizarre. You have to do it. I'm not doing it. Do it. So look, the brackets are very important. In an exam setting, the brackets are critical here. Please, everyone, you multiply this with this first, whatever the answer is, then you multiply with this one. Look at the bracket. I can give you till 11, 13 to 14. Okay. This format is also for everyone. Forget about the solution. Our solution method is different. You see, when you write that big formula, there is this small xyz that you see scattered everywhere. So this small xyz means this piston is moving towards this point. You see the slot. So as this piston goes towards right, this distance will keep on shrinking. So wherever you see a small xyz, this means the relative velocity of this with respect to this. Whether this is going towards this point or whether this is going away from this. When this is accelerating and options of velocity towards right, we have this intuitive feel that this is going towards this one, right? So that's why when I'm writing these equations and these are the unknowns to me, I just assume, let's say, that the arrow is downward. That's why if you look, I made an arrow towards here, that this is going towards it. And when you have an arrow like this direction, it has a positive I component and a negative J component. That is why I choose this part here. From the wherever I wrote EA with respect to C for X by B. EA with respect to C. You see, I wrote cosine of I in the positive direction, negative J direction. Now I will be trying to find good. And don't look at the solution. The bottom was written this as my answer.
as I this solution have this as minus, right? This as minus. That's why our W is different. Our answer is
Okay. Okay, so okay, everyone. What did you get? Okay, okay, so I will come on. From where should we even start? So I will have a okay. Should I just write the final or okay? Should I skip everything and just write down the final equations?
Yes.
Okay, so it is in my notes. I have in the previous time I wrote um, zero j. So I wrote it as 1.5 equal to I think I hang on for a second. I don't know how did I even write it. Anyways, so I don't know. I don't have that. Did anyone do it? Anyways, okay. These are the final answers I have. A with respect to C, small XYZ I get equal to minus 3.201, which is a big hit for us because our intuition is coming out to be wrong. And my alpha comes out to be 32.7. The answer comes out to be positive. So the maths is agreeing with my intuition. But now the maths is telling me, you know what? It is going upward. I mean, I apologize. Acceleration is in the upward direction. Okay. Is there anyone who wants me to go through this drill? I cross J equal to K and every single thing, or can I skip it? I think we have done it 1 or 2 times. Huh? Skip it, right? But you have to give me the answers. Are you actually getting them or not? How much? Because it is wrong. You made some time mistake. 100%.
8.1.
That's it. Are you rounding off? How much are you even rounding off? Oh, anyways, it's fine. Okay. Should I proceed? Yes, no. Yes. Feeling good? Everything is fine. Okay. Okay, everyone. So, okay. I don't think we need a break, right? Sure. Okay, let's have a vote. How many need break? Okay, that's like big majority. 1, 2. Huh?
it's all right.
Well, kind of, but okay. Since you brought that whole right thing, let's have actually a break. 11:20, we are meeting again. And during the 5 minutes, if there is someone who is really puzzled by this, why don't you raise your hand and I can come to your desk and I can help you. Okay, bye bye. 11:20. Anyone who is super confused? Okay, I will. And the answer came out to be positive. So math. Okay. Okay, which part? So you why didn't we first of all, I want to ask what which part was skipped? I did not skip anything. I'm saying, you see, in the bracket I have minus 0.5 cosine 50i and plus 0.5 sine 32. All I am saying is multiply 0.5 with the cosine 30, 0.5 with the sine 30, whatever the answer you have, and multiply the k unit vector with the I unit vector, the k unit vector with the j unit vector. That's what I'm saying. You have to do it. Once you get your answers, then multiply the outside k unit vector with the inside unit vector and the inside whatever you are getting from inside. So you will have some i's and j's that will be scattered. Then you arrive here, negative alpha k unit vector. You multiply k unit vector with the I unit vector. K plus I is a j. I will have a j component sitting here. Then you multiply the k with the j. This one, negative alpha k. You will get, I think, negative I. So you will have I, j, j scattered. Then you compare the I with the I and the j. This
So,
I have
so
already
let's
done.
say we assume, so no matter what the sign is, we will get the same values, but just a different sign, right? That's what we like.
No, for example, right
If
now.
I didn't have like minus alpha k there. just
Oh,
the same.
good. If you have a positive alpha,
Assume that.
if you had assumed anti-clockwise and your alpha had been positive there, positive alpha, then here your answer would have come out to be negative. And the maths would have told you, maths
The
would have,
values will be mistaken.
in one particular scenario, if you have all your intuition wrong, sometimes this maths plays this crazy trick and your answers can be a little confusing, but that is a very small possibility. As long as you follow a clear intuitive path, this is what I'm
So we
doing.
don't always have to, I guess, like try to figure out which direction is actually going.
Intuitive, I'm wrong.
These are difficult.
I'm wrong. Here I told you that my intuition is that it is accelerating
C
towards
will,
C.
C will accelerate towards A.
Whatever, and vice versa. Or, yeah. So my intuition is became wrong. It is telling us that this small xyz, this piston was not accelerating towards C. They are actually there is a deceleration. So answer came out to be wrong. But you have to, all I'm saying is multiply the k with the I and k with this.
Will you give us the equations in the example?
Equations are given to you. Don't worry. Equations will be given to you. So just so that
Really hard to like memorize everything.
no. Equations will be given to you just so that I will say you multiply this with the this. And you are allowed to, yeah, okay. So this is another thing. It's a possibility that I specify the coordinate system as well. Because just imagine I have a lot of students, and if there are few students who change it, make a different coordinate system. So for me, it becomes a little, so usually what I do is I specify the coordinate system. So I will here tell you, okay, and let me use a yellow color. Then k with this I, then multiply. Okay. I think we have, I think we did one time, right? Through the last class, I went through all the steps. So I think I can skip, no? Okay. Okay, everyone. Okay, now we can. Okay, that's now a nice, beautiful problem for everyone. Okay, we have. Okay. We have this as 0.5 feet. Come on. Okay, let's say this is your point E. I have skipped. Oh, didn't I? I wanted to skip one page and was thinking that probably. Okay, anyways. So this is my omega. Yes, no. That's your omega. Internet connection became unstable. Omega is nice and beautiful. 15 radians per second. And alpha is nice and beautiful. 2 radians per second square. By the way, in midterm 1, fall 2021, this was something similar I gave in the exam, I think. Okay, anyways. Okay, and then the questions say, okay, you have to come up with the coordinate system if I don't specify. You put it here, no problem. You put it there, no problem. Just put it somewhere on the paper. So, okay. So this is my small x, capital X, whatever. No, yes. Actually, you even don't need small xyz here. I'm sorry, yeah, small xy here. So, but as I explain the problem, you will understand what I'm saying. Hang on. Did I used to write small xyz? Yeah, okay. There was small xyz in this problem formula, right? There is a xyz. Ah, okay. Yeah, but yeah, here there is no need of small xyz. But anyway, since you have done that topic before this one, so I will just explain you completely. This is your ground. So this is your tire, disc, whatever. First of all, is this considered as a rigid body kinematics like previous example? The answer is yes. Why rigid body kinematics? Because I gave you its radius. So its size matters to me. Is this problem a rigid body kinematics problem? Is it rigid body kinematics? Yes, because the size, the dimension, it matters to me. The aircraft is flying like this, and find its acceleration, find that, find this, find that. All those problems that we were doing a couple of weeks back. Was that rigid body kinematics? No, that was point mass. The size never mattered for me. That was a chunk that was going here and there. So when sizes become important, it becomes rigid body. Okay, so I don't know. Let's do this problem. The question says that this point of contact of this tire or disc or wheel, this point of contact is C. The question says, give me the find velocity and acceleration. Everyone has gone through fluid mechanics, right?
No.
Okay. Find velocity and acceleration. You will understand why I asked for students who have gone through of point O and D. Very nice course, fluids and heat transfer. If a no slip, so somebody who has gone through fluids, yes, right? You have gone through. No slip condition exists. I will explain. No slip condition exists between the wheel, disc, whatever you want to call it, tire, whatever, and ground. Okay, what is the meaning of no slip condition? Good, very good answer. Everyone, in an exam setting, I will be just using this wording and you have to figure out. No slip condition exists that the VC will be equal to solution. VC will be equal to no slip condition means VC will be equal to 0. But I did not tell you that AC is 0 or not. We will talk about it. VC is 0. Because when the disc is rotating on a ground, the point of contact, you have a ground and you have the disc, right? If there is no slippage that is happening, then as this thing is rotating, yeah, this one, right? Okay, that's not good. Anyway, this, right? Right at the contact with the ground is at 0 velocity. So VC will be 0. Okay, I'm just adding one more comment. If there was a wooden floor and I was pulling it, hello, right, everyone, I need everyone's attention. If I'm pulling it, right, so if I'm pulling from the bottom, let's say, and I tell you that this thing is pulled at 2 meters per second, then in that condition, the no slippage condition would mean that the VC is 2 in the positive I. If I had pulled it towards left at 3 meters per second, then no slippage would have meant that the VC is minus 3 I. Good. But here the no slip condition means it is a ground. So VC is 0. Okay. Good. Yes.
Where is the B point?
C is this one. Which one?
No, B. You said velocity and acceleration of point O and D.
D. Oh, that is a good question.
Will it be E? Or
Where is D? Oh, well, I have to look at the problem. That's strange. Actually, I don't know. I think it's E probably. Yeah, probably. You are right. Thank you. Let's make it E. That's funny that there is no E. Okay. Okay. do it. So the first thing in this problem is that you have to write the formula. So what is the formula? It is V O. Okay, so it will be V O equal to VC plus omega OC, CO, CE, CB, CG, whatever, as long as all the points are on the same rigid body, the omega is the same omega. Omega COOC, whatever, position vector of O with respect to C. Okay, this is the point, but what you have to understand is from here onwards, it would be considered a joke to even write another term because it's a rigid disk. Point O is not running away from C. C is not running towards O. It's a disk, right? Point O is not a human that can just start walking towards C. So from here onwards, you don't even need to write anything. But just because you have gone through that previous topic, for the sake of completion only, which again is just a joke to even write this here. But I will not forget to use a big arrow. No, it's ridiculous. Point O is not running away from C. Come on.
If we assume that this ball was
Disk, yeah.
this was software like a dot. Can we say that there was a velocity, relative velocity?
Then that is not rigid body. Then if it had been soft, oh yeah, then that is a different scenario, but then that is not rigid body kinematics. This is rigid body simple kinematics. If point O is okay, let me put it this way. Good. He has brought this question, so let me change the question like that. Yes, we will talk about it. So your question is something like this. That what if I have a slot, right? I will tell you. And in that slot, I have this cylinder. Are you getting my point?
Yes.
Yeah. Right. Okay. So it's the same thing. Yeah, for sure.
It functions for the still the soft body.
It's not soft body, but yeah, now you have a chunk that is going outward, inward. So this blue fellow for me is like a human or like some disc cylinder that can go back and forth. So now I have velocity of what was that? O. If I am calling this chunk as O, so with respect to C small x y z, we'll have a non-zero count. Good. But I think we have covered these things. So good. So oh come on, what should I do now? Just finish this. What is VC? 0 plus. Okay, what is the direction of alpha? Again, this is a big mistake from my side. I have to provide to you the direction. So I am giving you for this question that alpha is also clockwise. Okay, omega OC is clockwise. That is negative 15 k unit vector. Position vector of O with respect to C. O with respect to C. Position vector. Good. Position vector of O with respect to C. 0.5 j O with respect to C. Everyone is in C? Right? Yeah, everyone. O with respect to C. I'm looking at O with respect to C. I look upward. 0.5 j. No? Ask me the question. Why are we what? Because I have made a big coordinate system here. Y is upward. O with respect to C is J. Okay. So give me the answer. 7.5. Good. K cross J is Negative I? Negative I multiplied by negative is a positive I. Is this answer right or wrong? Is this answer right or wrong? Right. See? Right. Clockwise. Clockwise, right? Clockwise omega. Look. It's going in the I direction. So omega is clock. It goes towards the right. The center of mass goes towards the right. The disk goes towards the right. The velocity is towards the right. The center of mass is going towards right. Okay. Oh, come on. Even in my previous classes, if I had asked you the question, you would have said velocity is r omega. And you would have immediately done 0.5 multiplied by 15. And it is going towards right. Okay, good. Let me ask Tehshin Chan, is it clear? Okay. Give me VE equal to, okay, tell me the formula. Should I use C or O? It will be easy, but then again, that's more like your convenience. In an exam setting, you could have used C, you could have used O.
I would be easier to use. Oh.
I will respond to that. But before I answer this, let's go back. Can I? Okay, this is not the question. How should I answer? I really want to bring one thing to your attention. This is a pivot hinge. This is a hinge. This is another one. Okay. Just bad drawing. Okay. Okay. See? Okay. This is A, this is B, C, D. Can you write VB equal to VA plus plus plus? You can write. AB equal to AA plus, that whole thing you can write. Okay. VC equal to VB plus omega cross whatever, plus whatever you can write. AC equal to AB whatever you can write. AD again using C you can write. Can you write this C equation with respect to A? Are you allowed to? No, we are not allowed to, because this is rigid body kinematics. So for one rigid body, I will be using my equations and I will be happy. Then I will take another rigid body. On that rigid body, I will be writing that big ginormous equation and I will be happy. Same situation goes for CD. You are not allowed to write C with respect using A or B using D. No. So on one rigid body, you use these equations. So let me get to my point. In fact, for the last week problem, the same thing I want to emphasize. You have to be careful. Now tell me, am I allowed to write these equations on this whole body? Oh yes, because this whole thing is one rigid body. I'm not worried about using any point. His question was, why using the point O will be easy for us, right? Because O and E are on the same line. So he's right actually. VE equal to VO plus omega. EOC doesn't matter. Can't care less. Position of E with respect to C plus, again, from here onwards, it's a joke. Don't even write it. But since we have covered, oh, it's just a, sorry, yes, thank you. Plus, again, it's a joke that we even bother to write this term. Like, come on, no need to even write this. Oh no, this is just big red 0. Don't. Okay, what is VO? 7.5 plus Now, yes, omega EO is clockwise minus 15. Oh, come on, this color is not, yeah, minus, okay, clockwise is minus K. Position vector of E with respect to O. Give it a shot.
0.
Position vector of E with respect to O.
Minus 0. Plus.
E with respect to O is minus 0.5. I.
Yes.
Because E is to the left of O. Okay, E with respect to O minus 0.5 I plus 0. Food for thought, something to think about. Could you have written VO equal to VE plus omega EO cross position vector O with respect to E? You could have written the whole equation. You got my point. Yeah, you could have. You could have written, but why would I want to? This seems easy to me. Okay. Okay, for students who did not get this point, I will again emphasize. I could have said VO equal to VE plus omega EOOE doesn't matter. Cross position vector of O with respect to E plus 0. So now VO is known to you. This is unknown to you. This you can find. But then at the end of the day, you have to take one term to the left hand side. You will get the same results. Okay. Okay, give me the answer. You already found it? Okay. VE comes out to be 7.5 I. K cross I is J. So plus 7.5. Does it make sense?
Yes.
Why?
Because it's going.
Right. Good. I will actually make the diagram. So velocity of E is 7.5 I. Really? Oh yeah. The whole object is going towards right. Every single point is going towards right. So 7.5 I. But the funny part is that since the disk is rotating, this point also wants to go upward, right? Correct? Okay, makes sense. So what is the resultant? It goes like boom. The point is going in this direction. Okay, seems correct. Okay. Is this fine? Okay, next problem. I'm not doing it because you do the problem. Do 2 parts to the problem. Give me the acceleration. We have a lot of time. How much time we have? 45 minutes. You give me the acceleration of point O. If you are able to pull this off in this class, then you will also give me the acceleration of point E. You are doing it. 45 minutes. I'm not doing anything from here. You have to do it. It's going to be very hard because acceleration of point C is not completely 0. It will be tricky. I will explain when you do it. Okay, I think I can give you a hint. Otherwise, you will not be able to proceed. Okay, at least write the equation for me. Yes. Okay. Hang on. I'm sorry. What is the? What did I ask you? Give the acceleration of what? Hang on. But what about acceleration of C? Yeah, you also don't know that. Find the acceleration of C as well.
Acceleration at O is 1.
Yes.
Acceleration of O. Okay, acceleration of O. Acceleration at O should be alpha r, by the way, but you will see. Yeah, good. How you figured? Okay, good.
I just tried
Good. Acceleration of O, he already found out. That's good. There was somebody who asked a question. Yes.
Acceleration of C will be not 0.
Not zero.
Because this is turning, because of that, C must be
Normal. Good. Normal component of acceleration should exist because this is curvilinear motion. The point C is following a curved path. So there has to be a normal component of acceleration.
and also tangential.
AC will not have a tangential component because of no slip condition. Okay. Well, this is tricky for everyone, I guess. Okay. If you have started to think, then I think the job is well done. I will actually write the formula and then I will start. Okay, let me go back by the way. AO equal to AC. AO equal to AC plus omega OC position vector O with respect to C. Sorry, again, a mistake that I am making too many times now. There is actually a bracket. No? Yes? Omega square R, right? From our maths classes, physics classes, plus alpha or omega dot O with respect to C plus the Coriolis acceleration. I encourage you to see a YouTube animation, by the way. It's a little hard to imagine because of the fact that omega is also in the K direction and you have O/C as, oh, hang on. In this problem, we don't have these components, right? We have already talked about it, no? Small xyz are not here. So, oh, come on, don't even write them. And if you have written them, then put big zeros. Okay, I think now let's talk about AO. Well, what is the direction of acceleration of O? When this disk is rotating going towards right, as far as the center of mass is concerned, what is the direction? Towards right. There is no curvilinear motion for this point O because poor chap is sitting right at the center of the disk. Are you getting my point? There is no normal acceleration to this. For this point, oh yeah, this object has a curvilinear motion, so I won't be surprised if there is a normal component of acceleration. So anyone who can tell me what should I write if I have removed the arrow? Only I. I told you that this fellow is accelerating only towards right, doesn't have any component up and down. Okay, so equal to, this is the part that becomes now confusing. AC, this point, because of no slip condition, will not have any tangential acceleration. So the only acceleration it is allowed to have is normal, because it is sitting on a curvilinear path. So I will write ACJ, and the rest of the problem is a game over. Plus, what is omega? Minus 15, right? Clockwise. Now there are many students who are getting confused by this, so I will remove the confusion by doing something at the end. Okay, cross 0.5. What is the position vector of O with respect to C? Because of this coordinate system, 0.5j, I think. And plus alpha minus 2, no?
No, not for.
2. Hang on. I forgot. 2 minus 2. Okay. Cross 0.5j. And look, everyone, if you're finding it very hard, look, everyone, if you're finding this very hard, imagine like this. You have this whole disk that is going rotating like this, right? It appears to be rotating about point C, right? Because point C is the stationary point for me, and the whole chunk is going towards right. So think it like this, that the center of mass O has an acceleration of alpha r towards right. That's, I think, how he immediately told me the answer as well. Alpha r, what is alpha? 2. What is r? 0.5. That's why the point O has an acceleration of 1. Again, it's just different perspectives with which you can solve one problem. Equal to ACJ plus, okay, this one I can help you. K cross J is K cross J is minus I, and minus is plus I, and then K cross I is a J with a negative sign. So minus K cross I, that will give me a minus J. K cross J is negative I, negative, positive I. K cross I is a J, negative J. So I will put a negative. Okay, internet connection is unstable. Okay, 7.5 multiplied by 15.
So we forgot cross to omega or C.
Say that one more time.
Plus 2 omega or C.
0. That is 0.
What?
This term is 0.
No, one on the left. Oh, yeah, that, you missed that.
Yeah, but this whole thing is 0. So when something gets multiplied with the 0, the whole chunk is gone. Yeah, that's fine. So, okay, what is 7.5 multiplied by 15? Calculator.
105 times.
Okay, everyone. 112.5. Okay. Then this is K cross J is negative I. Okay, and this is 1. So I think that's how very quickly one of the students figured out. So I will have A naught equal to 1. 1. Yes, I and I. Okay, and 0 equal to AC minus 112.5. So this gives me A naught equal to 1 meter per second square. Sorry, feet per second square. I think this problem is in. And this gives me AC equal to 112.5 J feet per second square. Now, here comes the important question. What is the direction of AC that I assumed? Upward, right? Boom. What is the direction of A naught I assumed? Towards right. Boom. Confused? This is the part 70% of the class did wrong in midterm 1 for 2021. Every single person said AC. Most of students said most of the students said that AC is a 0 for no slip condition, which was wrong, as AC is not 0. I will take your question. I have to double check on that. Yes.
For AC, we said that just J component is just normal component exists.
Yeah, that's why I did a ACJ on it.
Oh,
That's why I wrote AC only J.
how can we be sure that the J, the just normal component exists?
I will explain. I will explain because I have already mentioned that this point is not going anywhere because of no slip condition.
Okay.
Right? Okay. If this point is not going anywhere, its velocity is 0.
Oh, but yeah, velocity is 0.
Huh.
I get it, that part, but let's say, we are looking at instant time, right?
Huh.
We are looking at
Good. Instant, very good. At one particular instant, very good.
instant. So velocity can be 0, but acceleration may be in
Good, good.
direction. Therefore, the C
Good.
goes like
Huh.
this curvature.
Good, good. You're right. You're right, actually. I completely get your point that at this particular instant, yes, but of course, this point is, if we put it on a disk, it is actually, I get your point. But at that instant, at that contact, the velocity is 0, and therefore the tangential acceleration is also 0. The normal acceleration is non-zero. I'm not sure how to emphasize it in a better way. But this is the explanation, because no slip condition at that contact point, disk is rotating momentarily because it is in contact with the surface. For me at that instant, the VC is 0, and hence there won't be any tangential component of acceleration whatsoever. But since it is on a curvilinear path, normal would be there. But that's the only explanation I have to offer.
So, for example, we have a laser here. And we said that the velocity is 0, but for example, there is an acceleration on this laser.
Got it. But
So
laser is not circular, but
yeah, we're just looking at instant. So there's an acceleration, but velocity is 0.
I get it.
This
Actually,
can be pure. So because of the
I do understand your question, but no slip condition. Yeah, tangential acceleration is going to be 0. But I do hear you. We can think about it more, but that's it actually. Tangential acceleration has to be 0. It's the same thing. I'm not doing it like this. Probably you might want to. You have to. Okay, why don't we go to this one? This one. Everything is fine. Everyone.
Can I ask you a question?
Yeah.
Can we say AC
Uh-huh.
instead of AE? Sorry.
1 minute. 1 minute. I did not understand. Can we say what?
Can we say AE
AE?
instead of AC?
But no, right now, no, because AE is completely unknown. Look, I understand your question. Look, this was a good question. Look, AO is right at the center. Disk is going towards right. Since it is at the center, There is absolutely no curvilinear acceleration, hence no normal acceleration to point O. So fortunately for me, there is no J component for O. That's why life is beautiful. You write, you said writing AC by using AE right now? Even before I tackle the O? No. Then, because AE will have two components. The point E is in a curvilinear path. It will have a normal component. It will have a tangential component. So even before you do this, you will get yourself in a very uncomfortable situation in terms of maths. Now that you have done this, now you are in a very comfortable position. Now do whatever you want. Now you can write AE. What happened? Okay. Okay, AE. This is definitely you are doing it. Do it. Do it. Good. So clockwise is negative. You get equal vector, and anti-clockwise is positive. Because I cross A is 8. That's what I'm using. So if my coordinate system is like this, then whenever I talk about omega and alpha, so clockwise omega and alpha I will take this speed. So anti-clockwise omega and alpha I will have positive speed. If I have such kind of coordinate system in my y and x axis to be like this, then y is in this direction.
One 2.55.
Which one? AE? You got it so quickly? Wow. I don't know actually. I don't know actually. I don't have the answer. I have to do it. So I think I can do it with you. Which point should you use? Yeah, seems easy, right? O is easy. Someone is planning to use C. I don't have issues, but oh, come on, it will be. You have to find minus 0.5 cosine 45 and I don't know. Okay, so let's do it. AE equal to AO plus omega EO cross omega EO cross. By the way, what is the name of this acceleration that I'm writing? What is the name of this? Name of this acceleration component? Just tell me the name. Plus alpha EO position of, you already know the name by the way. Student, yeah, students are just hesitating. Very good. Normal. And what is the name of this? Tangential. I think you already know the name. Okay. Plus, oh, come on. No need to even write this, by the way. It's just super funny that we even want to write this. How on earth can Coriolis enter here? Oh no. Big no. A, E with respect to O? Oh, come on. No way. Small x, y, z terms can enter. Big no. Okay, give me the answer, everyone. So what will be the AE? AE will have, okay, now it's going to be confusing. AE, okay, done. Then what should I write? Like this? Are you sure? Like this?
Yeah.
Uh-huh. No, I will tell you why. Look, what you are telling me is that E will have two components, I and J. I agree. Are you with me? No, you're not. So, no, you're not. Okay, anyways. My question is, why did I write AE, I and J? You are telling me that AE has a I and J component. I agree with you. Will it have equal components?
No.
You see my point. What you are telling me is that E and I and J have equal components, which is wrong. Huh? So we will have you get my point.
Wow.
So this was a very classical mistake that you can end up having in a pressure situation. Now, what was the acceleration O that you calculated? I don't remember. One in the I. So it is 1I. Okay. Then I have plus, what is the omega?
Hocam we have already completed that entire chunk.
Sorry?
Isn't it the same? The normal acceleration, isn't it the same?
Yeah, I think we have, no? We have.
100 and,
Okay, I think he's right, no? No, E with respect to O, we haven't. E with respect to O, I haven't. E with respect to, did we do? How we did?
or respect to C.
Okay, hang on. What is AO? Let me go step by step, please. 1I. Okay. Plus, what is omega EO? That's my clockwise. Minus 15K. Cross
0.5 I.
minus 15K cross position of E with respect to O is minus 0.5 I. One of the students has told us, he's right. Thank you. What was alpha? In the clockwise? Minus 2K. Position of E with respect to O, minus 0.5 I. Okay, everyone, why don't you do that for me, please? So A, okay, I'm not doing it. Okay, I plus K cross I. Oh, just K cross I is a J. So let me just do it. Minus J. Really? Good. K cross I is a J. Okay. Then this is, I don't know, just do it, please. This is K cross I is a J. Okay. Can you please give me the number? What is I plus?
114.5.
114 point? No, 12. 12.5 I. Okay, then 1 J. Okay. K cross I is a J. Okay. And oh, come on, internet is unstable. Why? Okay, K cross I is a J. Please double check for mistakes. K cross I is a J positive. K cross J is negative I, but I have negative here, positive I. Okay. So my final answer is 113.5 I plus 1j. Oh, wow. Okay. So I have AEXI plus AEYJ, right? So now you write AEX will be 113.5 and AEY will be what? I think in the next week there will be a complete problem on this. I did it a little early, but that's fine. At least you had some practice now. Meter per second square. Meter per second. Okay. It has a big component in the X and rather small component in the Y. Next time we will talk about it more. You can double check for mistake, by the way. So it is I, K cross I, J, positive, K cross J is a negative I, positive I, plus K cross I is a J. Okay. Okay, with respect to O. Yeah, okay, I'm skipping further details right now, I think. Okay. Okay, so yeah. Huh. Yeah, why not? Okay, hang on. You can ask me questions. Which theorem?
Are they components? AEX and AEY. So you can use the you can find the magnitude AEX.
Yeah, of course. I'm skipping that right now. You are right.
That will be just equal to AEX. One is very small.
Oh, no. Don't do that. I understand your question, but this is the acceleration. Oh, yeah. That's why I am also skeptical about the answer. I hope there is no mistake, by the way, but we will double check. I don't think there is a mistake, but yeah, one is small, but small, not zero. Do the square of this, take an under root. I see where you are coming from. Your point is when you find the final magnitude, it will be, yeah, but no, don't do zero. Okay, should I go back now? Okay, so if it hadn't been hybrid teaching, this would have been your quiz. So do it. I'm not doing it. I'm just layering one more piece to it, just so that there are no confusions whatsoever left when you leave this class today. So now we are filing one more concept. Oh, come on. It is tangent and I will try to make a circle. I hope I have ended up making one. Yep. This looks to me as a circle. Okay. Now the question says that you have, this is more like a rack and pinion configuration. Are you getting my point? This is your, let's say, rack and a pinion, and my velocity of this gear is rack, I mean, is unknown, and this is my point B, the point of contact. This is my point D. Okay. Yes, no. This is my velocity. This is my center. Nice and beautiful. A. And the question says that what if this fellow is rotating nice and beautiful on a ground? Are you getting my point? And the ground is like this. The ground is named a little point C. The radius is R1. I think this is going to be your take-home problem. I highly doubt we can do it today. And this is my R2, sorry, R1. This is my nice and beautiful R2. How many agree and how many disagree? This is my point. Omega is shown like this. Correct? This is my point D. Oh, didn't I name that, by the way? No, I think I made a mistake. Sorry for that. This is not your D. No, absolutely not. This is D. Yeah, mistake. The question says that if this fellow is going towards right, the A, with a velocity of 2 meters per second, sorry, 1.2. Too many mistakes in one class. 1.2 meters per second. And this is a no slip condition happening. What does that mean? Good. Quickly, very good. BC is 0. Your R1 is 150 millimeter. And my R2 is 100 millimeter. Then give me the velocity of B. Are you getting my point? This velocity that I'm finding of rack is this VB, this V, 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 everything is same. Good. Okay. So V equal to question mark equal to V rack equal to VB equal to question mark. What are the coordinate system? I am going to give you, so all of us are on the same page today. Okay. By the way, what was the question? VB. You can also add one more question to it. VD equal to question mark. And you can also fill some colors if you are comfortable. So students are allowed to fill some colors. But I think okay. That's nice coloring. Okay. You can color it completely. I'm not doing it. Color it. Solid objects. Do it. You do it. Quickly. Do it. Do it for me, please. So write the question. No, you write the question for me right now. Right. Okay. P is that point, right? On the top. P equal to. Okay. No. Okay, this is good. Did I give you omega? No. So how can you find omega?
We can divide the velocities by this.
Good. But look, don't divide it directly because that's the whole point of the methodology of it. What I want you to do is write the velocity of A using C. So write completely. I understand that you can directly know it, but VA equal to VC plus omega AC cross position of A with respect to C. But you just told me you will get omega that to C. Go through the vector part. IJK. I didn't want to do that, but I see what you just said. Once you are done with it, then write the VB using C or A. First write A using C, then write B using A or C. Find it. So write VA equal to VC plus omega AC cross position of A with respect to C. VA is known to you, VC is 0. The only unknown in the equation is omega. So it will be. I understand what one of the students said, but I really want you to go through the complete drill. So I will say VA equal to VC plus omega AC cross position of A with respect to C. Next terms, I'm not going to even bother about them. Like, come on. Okay. VC is 0 plus omega AC is, don't know, it's going right. So probably it's going clockwise. Remove the arrow. A with respect to C is 150 in the J direction.
Yes.
I think you're right. So VA is 1.2 I equal to, what is K cross J?
Minus I.
Okay, and we have 0.150 omega AC, right?
Yes.
So that's why you, one of the students directly told us the answer. What is omega AC?
8.
Sure? 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 Okay, radian per second. My intuition is correct. Clockwise, life is beautiful. Okay, then. What was the question? VB. Okay, VB equal to. Should I use point A or point C? Doesn't matter. In fact, you could have, some of the students might have even disagreed with me on this. They could have said, why aren't you even using B? VB equal to VC plus everything. You could approach this problem any way you want. So VB equal to whatever. I'm more comfortable with, I don't know, C probably. VC plus omega. This whole object is a rigid body, right? Omega here will be the same as omega here, 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 here, omega, omega, omega. Everywhere I have omegas that are sitting. Okay, so omega BC, CB, whatever. So position of B with respect to C. Look, VC was 0, so I wanted the easy path. So that's fine. Oh, come on. Now VB is equal to my velocity of rack. It is equal to. You got the answer? Okay, 0. VC is 0 plus. What is omega BC? Minus 8K. Who said that? Correct. Cross position of position of B with respect to C is 250. Correct? Everybody got that? Okay. It is J. Okay. What is the VB you are getting?
It will be 0.15.
No, no. B with respect to C is 150 plus 100. No? Huh? Okay. Okay, give me the answer, everyone. Sure. K cross J is negative I. Negative, negative, positive I. Okay. And you said 2. 8 2s are 16, 8 5s are 40. Sure. Okay, 2. Okay, okay. Yeah. Good. Thank you. Okay. The answer is, oh, come on, the answer needs to be right. I don't know why I forgot to write the answer here. My answer here is 0.25 times omega. Am I getting 0.25 times omega?
Yes.
Sure. Okay. Okay. So what is B? It is velocity of rack. In which direction? Towards right. So somebody has this rack with which this, not somebody, but it's a mechanism. And the rack is going towards right. The pinion is going clockwise. Questions? You could do this problem in a dozen ways. You could have said VB equal to VC plus something, VB equal to VA plus VA equal to VC plus sky is the limit. Your take home task is you need to give me next time VD, which is the point sitting here to the left. Yes, no? Oh yeah, I will. What is the acceleration of point C? 0 or non-zero? Acceleration of point C is 0 or non-zero? Non-zero? Good. Good. Because there will be a normal component.
O da yeni başladı.
Okay, thank you. Thank you, Tashin Chan. Thank you. Bye bye. If you have any questions, please ask. Look, if there is any student who even has 1% confusion on this one, please don't hesitate. I can do it next time. I can do it in office hours. I thought we have already gone through this drill in one class, so I skipped it. Please don't hesitate. Okay, bye bye. Okay, what happened to this plug? Okay, we are. Oh, gone. Good.
Tam geliyorum ben şimdi. Hocam,
Yes.
I have a question about this normal acceleration and there's no tangential
Yeah,
acceleration.
at that point, actually, look, even see,
I get it for hocam. Like when there is no slip
When there is no slip,
When there is no slip, the
so the fact that you are saying that this center is accelerating at alpha r, how do you say that? Because you are saying that the whole object is rotating about this point. So all this point is going through is alpha r. So there is no tangential acceleration here. I'm very good. I'm sure. So this point of contact does not have a tangential acceleration. In the no slip condition. I will be answering your question. You can stay with me, but I just need to give him the time. You stay. I will just because I'm no. I'm giving you time. What is your name? Please. No, this is my this page is for you. Okay. No, this is the next. Okay. Hang on. You know, I will have to give time. You have to give me this little room that many times I cannot reply to you. So it's not that I didn't want to, and I'm also making you wait. Okay. I am busy from 3:45 to 4:45 today. Other than that, I am free. Tell me the time. You're available right now? Okay, so let's meet in my office at 12. How much time do you want?
just keep this
12:45. We are meeting at 3:29, 12:45 p.m. today. Yes.
So we are thinking that this project in our question it goes right. While goes towards right, there's no slipping. Because of that, the
Yes.
object is turning.
It's there is no slippage, and that's why the whole object appears to be rotating about this point. There's no slippage, and that's why if you see
So
here,
therefore, there is no acceleration tangentially.
exactly, that's what my whole point is that look, this object is going in this direction with a VG, center of mass, has a velocity VG, and this point is also accelerating in this direction with AG, because this point is definitely not accelerating up or down, because this center point is not following a curvilinear path. This center point is having a very translational
Yes.
angle to it, right? A translational way. This is why you see that since no slipping occurs, the author just said AG equal to alpha r. You know why this author wrote this? Because he said in the I direction, this point is not going anywhere in terms of its acceleration. So towards the right, I have alpha r, and I went one step further. I just said, if you're talking about finding this acceleration, you will only see that you will have a j component, which you will find it from here, that your AA only has a j component, that too because this fellow is sitting on a curvilinear path. So in the I direction, my point A, because of no slipping, has no acceleration. But it is a little hard to
Imagine. It's hard.
this is why in the second or third class, I remember I said this one second. Acceleration is always very hard to think intuitively. So hard.
Absolutely,
Yeah.
hocam, absolutely.
If I tell you that acceleration is constant, but tends to have a very wrong feeling about it. Acceleration is constant. No, acceleration is constant. That means velocity is increasing with very nice equal steps.
Yes.
Velocity is increasing if acceleration is constant. You see?
Acceleration is zero, there's
Yeah,
no
then so
velocity.
that's why I always say, let me pause it. Okay, so just go over our O2 class. There are a lot of notes